Now the advantage of doing that, obviously, is we'll actually have a video record of this meeting, so we will on YouTube, and so if you have folks, friends who didn't make it, but want to check it out, we will be able to do that. And I wanted to start off, first of all, by saying there is a sign-up sheet going around. Let me know who you are. I'm trying to keep track of who is coming month to month, and regular attendees, new attendees, and old attendees. I'm looking also for some ideas, and I don't know if there's space on the sign-up sheet, but if there is, avail yourself of it, or in the kind of space below your name or something. Topics you'd be interested in talking about in months ahead, in future meetups. It was a great talk today. IoT standard focus, which I know is a topic that has come up many times in other meetups and that people are generally very interested in. Tina and I were talking on the way in, real world IoT implementations and concerns vis-a-vis security, privacy, data integrity. I know it's a big one, and I'm going to be working on that to get some folks, whether it's from the smart city or industry, to come in and talk about real world IoT deployments. But if there are other issues that are of interest to you as a developer, as a product manager, as an executive, as an entrepreneur, around this general topic of security, Internet of Things, connected devices, and all of its various implementations, all the kind of idea cloud of topics that are around security and IoT. So it could be endpoint security, could be security at the management tier, could be comms, could be different platforms, could be like standards, identity, all of the various management, provisioning, deprovisioning, whatever it is. I just struggle a whole bunch of doing but there's, I'm the least technical person in this room probably, so there are probably like 100 things that I can't even that's about it. So one thing I like to do at the beginning of each meeting, because this is a classroom setup, which is great for presentations, but terrible for networking. Ideally, there would be like tables with alcoholic drinks on them that everybody could avail themselves of and have a couple drinks and start talking and get to know each other. But we don't have that, and so what I like to do is just pass the mic around at the beginning of each session. People just sort of say a quick hello, who you are, where you're from, or why you're here, or both those things, and then we'll go around that way, and then we'll go along and introduce Brad and Nicole.
Hi, my name is Nitin Sonali. I'm an entrepreneur working on IoT security. Previously, I worked on mobiles.
Hi, I'm Radha Sushner, and I work in the UI UX side of things. And small company, I'm sure home about technology. It's mostly business to business, but some stuff can help. So interest in security is always.
And Ryan, I keep coming because I'm really interested in how the public understands these issues, and if the public has any use other than being a user to developers. I'm also very interested in how one reports.
Security,
Yes.
I'm Chris Windsor. I'm a software engineer interested in system integration. I've been working on trying to put together some demos based on the Prudix platform, and trying to use that as a start.
Hi, I'm Peter Quirk. I'm a product manager at Hitachi Data Systems, interested in security across a range of products and content.
I'm Dave Dimmoduck. I'm a semi-retired with 1 year military background.
Hey, I'm Jeff Spielberg, co-founder of a firm called River Security. We do secure embedded device design consulting and embedded device penetration testing.
Hello, I'm Albert Buckman. I'm from a company called Symmetrics. We do automation system analytics, and we're interested in IoT devices and systems.
Hi, my name is Roshan Thomas. I'm a graduate student at Northwestern University, and I'm also an application and networking tester.
Hi, myself Prasad. I'm following electronics. I want to know about the latest trend in the IoT plus more of security concerns. So this is my first meetup.
I'm a design and undergraduate student at Tufts. I'm interested in security. Hi, I'm a design and also an undergraduate student at Tufts, which I study computer security together. So this was opportunity. I'm Jingwen Zhang. I'm a consultant for a pharmaceutical market research company. I'm interested in internet-based application in healthcare IT in terms of privacy, security, etc.
Seth Kintai, embedded system security.
I'm Yaron Shurgai. I'm Draper as well. Maybe I'm not a system software security issue. It's a relatively new career step for me. Before that, I worked for a long time at Intel on low-level processor firmware.
Matt Zarzita, Director of Innovation with Talus Explorer over Innovation Group, interested in security, IoT, blockchain, and IoT.
I am Abby Lyons. I'm a business analyst at Novartis, and I just enjoy technology.
Hi, I'm Alan Killian. I'm a firmware developer for Xylete by LogMeIn. I've been doing edge system firmware and security for their IoT platform, and recently laid off, so looking for a new gig.
Hi, I'm Joe Boyce. I do technical and executive search with a particular focus on IoT platforms and security. So I'm very interested now in device security. So that's what
I'm Ian Petrie. I run a small software consultancy. We focus on new things as well as voice and voice.
You said focus on Internet of Things and what?
Voice over IP.
Voice over IP.
I'm Emma Love, and I'm a quality assurance engineer. And I'm interested in security Hi, I'm Steph. I'm a software engineer. I'm interested in potentially getting into security. I recently laid off from my IoT company. So looking forward.
Hi, I'm Greg Kemp. I'm a business teacher as
Steve McDonald. I'm a software engineer at Bose. I'm more interested in the smart home and how to get it going.
Hi, I'm Mike Spessner. I'm a developer and co-author of the book on network security. I asked myself my entire life, why am I here? I don't know. Hi, I'm Jeff Kohler, and I'm an IoT enthusiast and do some development with some sales and some marketing things around IoT systems. Hope Paul up with this meetup as well.
Awesome. So, yeah, the other big function of the group is connecting you with each other. So if you have, in the past I've offered, you're looking to hire, let me know. If you're looking for a job, let me know as well. And we have a LinkedIn group for Security of Things forum, and there's a real nice kind of job interface on that. So if you've got positions that you're looking, if you've got positions you're looking to fill, let me know. And obviously, if you are on the other side of that, help you out with that. Okay. Okay. I think we're ready to get going. Thank you everybody for sharing kind of why you're here and what you're up to. We have a great speaker lined up for you tonight. Brad, actually, have you spoken before? You were on
I did
on
the
a
hardening
panel?
one.
Huh?
I did device hardening.
Yeah, device hardening, right. Brad is, if you don't know, is the CEO of Beechwoods. He has 25 years of experience in embedded systems, operating systems, network protocol, device drivers. He's a respected technical rainmaker in the startup community as well as an entrepreneur. Might be a good guy to get to know. And he founded Beechwoods in 2005. Prior to that, he was director of software at Serenoa Networks. And he also served as an architect at Indies River, where he led the architecture, design, software development of the company's VPN product. So it's good security shops as well. He's going to be talking to us about Open Connect framework,
Open Connectivity
Forum. Open Connectivity Forum, and IoTivity, which is kind of their IoT.
It's an open source implementation of the standard.
Yeah. I think with that, I'm going to turn it over to you. You're on camera right over there, so just give away there. And you can either do it here.
I'll probably use this one.
Yeah, you can move over.
Hear me? So I'm Brett Kemp. I'm the president and CEO of Beechwoods Software. Beechwoods Software is a software integration services consulting company. We specialize in embedded Linux, embedded Android, and bare metal embedded devices. We're also active in IoT because many small devices are IoT based. Additionally, I was chairing the location services work group with an all joint that's moving over to OCF. I also, as of Sunday, am now the OCF ambassador to Boston. So if you have OCF questions, feel free to.
You get special license plates with that?
No, I used to be the all joint ambassador, but no. So I think, how many people have ever heard of the OCF before? A small amount. So OCF is one of the IoT protocols that are being proposed as the one to rule them all. A little bit of history, if you're old enough like me, you remember when networks were young, we had TCP/IP, we had OSI, we had network, we had banging lines, we had thousands and thousands of protocols. TCP1. Now we don't need that. And Apple Talk is dead. And a bunch of things are dead. We're now in the midst of that in the IoT world where we have lots and lots of protocols. This is one. One of them will win, I don't know which one. But 10 years from now, we will speak a protocol for all these devices. So what I want to go over is a little bit of the OCF, an overview of what the OCF protocol is, a little bit of the history of how it got to where it is, and then I'll dive into the security model. And the two models I'll look at is the IoTivity security model and the all-joint security model. On full confession, because I'm a member of the OCF, I cannot talk about OCF standards that have not been disclosed. And we're in a really bad time right now where most of it, 99% of it has been disclosed. But we're not going to release the OCF standard until a month or so from now. So there's a little piece that I just got to go, yes. So OCF is a RESTful API. You know, you do the basic CRUD stuff, where you just send stuff and hopefully it all works. It does use CoAP as the network layer. CoAP is the constrained something for tiny devices. It's TCP over tiny devices. And everything in an OCF network is a device, and it is either a client or a server, or a client and a server, or a server and a client. But there's only two things you can be. You can be a client or a server. Because it's RESTful, it has a few well-known paths, and then after that, everything's discoverable. So it's a few things to find it, and then so here's a little history. The OCF started as the IOC, which is the Internet, the IoT, no, I forget what it was. Something Open Connect.
Yeah.
It was, started in 2014. They got their first release in 2015. They acquired the UPnP forum. So the OIC was both the OCF protocol, the OIC protocol, which is now the OCF protocol, plus all of UPnP. So right there, there's a couple 100 million devices that speak OCF, or OIC. OIC 1.1 was released, and then the OIC merged with the All-Seeing Alliance, and they got the name on top, so it's one of those mergers where there's, someone wins and someone doesn't. And as a result, they changed the name to the OCF, and the OCF 1.0 spec, which is different than the OIC 1.1 spec, it's more advanced. So our numbers are kind of screwed up. It's soon to be released, and there's three pillars to the OCF. One is the specification, one is conformance, and the third is open source. So the protocol really isn't done until all three are met. And I'm thinking that sometime within the next quarter, that all three will be there, that we'll have the specification, we'll have the conformance test, and IoTivity, which is the OCF open source implementation, is actually funded by the OCF. We'll have all the pieces of OCF 1.0. A couple of things is that OIC and AllJoint had completely, or All-Seeing Alliance had completely different architectures. But the nice part about this merger was that the functions that were lacking in OCF was completely obvious, so they've been picked up. And most of the good stuff is going to be in the 1.0 release. But you didn't come here to talk about OCF, you wanted to talk about security, so Paul said make it security oriented, because I could give much deeper talk on OCF. So I want to go over a couple of things that the OCF security does. It covers integrity, confidentiality, access control, onboarding, provisioning, secure resource manager, credentials, and I'll go over secure boot because it's, although not mandated, it's highly recommended. Oh, and feel free to just ask questions. All right, so for integrity and confidentiality, all the links are DTLS enabled. So everything's encrypted all the time. Now there's a couple of different types of DTLS of encryption protocols we use for ciphers. There's the anonymous one, which just works, which is pretty common for, everywhere. But it doesn't really get you that warm, fuzzy authentication part. It just works, but it's anonymous. You don't really know who you're talking to. The random pin base, that's sort of the pairing with your Bluetooth. And then we get better, symmetric, the certificate based. That's great, but it's very hard to provision. Symmetric keys and asymmetric credentials. And even within this, there's a bunch of different standards that are supported, but those are the big families. Now, in each of these, one family is mandatory if you're going to support that family, and the others are optional. So, go ahead.
So DTLS is a UDP base?
Yes, no, it's TCP as well.
So what's the D part? I mean, TLS is what? Datagram.
Datagram.
Well, that's why I think it's a UDP base.
No, this is TCP. We're using it for TCP.
Okay, so regular TLS.
Regular TLS, yeah. I think there's an authentication factor in it. I can go look it up, but think of it as TLS.
TCP using TLS.
Yeah.
Okay. Yeah. All right.
So access controls. Now, access controls are obviously important. We're going to have a lot of devices out there in the world. I mean, there's going to be, according to the reports in 2025, 75 billion, which scares the crap out of me. So you got to know who can talk to who. I mean, I only want one app open in my room. Thank you very much. I don't want the toaster doing it. So you gotta know who's who. The OCF has a bunch of specifications on ACLs. Well, there's two types actually. There's subject-based and role-based. The subject is the device. What are you? And the role is what do you do? So you can combine some pretty good
And what's an ACL?
access control list. I can talk to you, here's, am I a read resource, am I a write resource, read-write resource, or am I going to just ignore you? So we're controlling access to the things, the properties of your device. What is missing is the actual, because it's only role, what is missing is the actual granularity down to the app. But anybody who says that they're a door unlocker can unlock your door, who's been authorized as a door unlocker can unlock your door, not just my door unlocker. We'll get there. So the scope of these ACLs, or the access control lists, is you have group level access, which is a bunch of devices. You can have device level access, where it says only this specific device can do it. You can have resource level access. So in the OCF, the interesting data on the device is a resource, and it's a path that you will go request with a GET. Because OCF is RESTful, you do GETs, and then to set them you do posts or puts. So that would be the resource level. And then below that is the property level. So you can put an access on a resource, which would be a piece of data that says this is readable by this other thing. But it's only one. You can only put one property ACL per resource. So if you have a complex resource, which is where this is supposed to be, so that's because it can be a complex resource, you can't have this part of the property being read only and this other part being write only. You need to split it into the two properties. I forgot about the verification. So there's two ways to verify the ACLs. One is a local-based thing where the device says, I know what's right. I will make the decisions. And the other is this thing called AMS, which is the Access Management Service, which is a specified service in the OCF. We go query saying, this device wants to talk to me, is it okay? And it comes back and says yay verily or no. So this moves it to a central provisioning system if you need them. Most of the devices right now have a local control, local access control, and not an AMS service. Onboarding. So you get your device, you plop it down there on your wherever you want to put it, and you got to make it join the network. And this is pretty tricky because you have to first identify the device. The device has to say, I'm ready to join your network, and then you have to do all the provisioning necessary and configuration to have it join the network. So what the OCF has come up with, maybe I didn't. No. It's an onboarding tool. And this is based for service. It's the onboarding tool is it's not really a tool. It's just a way you would build a tool on how you would take a device that's out there on the net and make it trusted and bring it into the trust zone that the network is. Because the network, the OCF network, does have trust relationships. You have to bring this device in and initiate with the AMS. There's a bunch of things. So what they've come up with is a trust transfer mechanism. So you can transfer trust ownership, device ownership to the provisionings, the access management service, or whatever it is that says now this device is now claimed, it's owned, it has whatever credentials it needs to play in the network. And the protocol is set up to do this so that it's well known how you do it. If every device tried to just do it randomly, it would probably be problematic. So this is just one nice way of bringing on board devices without having chaos in the world.
So this is like I buy a light bulb at a store, and I bring it home, and now I have to establish it as my light bulb, not just a light bulb in the store.
Yes, because you want to trust it. You want to make sure that you're going to allow it to talk in your network what the rules are. You do not want that light bulb opening, unlocking the front door. I mean, so you do have to bring a light bulb into this network. As we get more and more devices, it's going to be, it's going to be much more important.
Does this also cover if I like gift my IoT light to somebody else?
Right. It's the idea is you're bringing in an anonymous device onto a secure network, and how do you do that?
So it can tell you, like, I'm a light bulb made by Philips and I haven't been reprogrammed or something.
Right.
Like that.
There's a well-known path that says I am owned or I am not owned. And so if you're not owned, then the onboarding tool could go and provision you and set you. If you don't claim to be unowned, if you claim to be owned, then the onboarding tool can't. But also, no one can talk to you unless you present the proper credentials, nor can your credentials be reset. So you do need to be in the factory reset state. I mean, basically the way it is, you hold the button for 15 seconds, the lights blink, and then you're in the unprogrammed state or the unowned state. An onboarding tool can come along and provision you such that you're now trusted in the network.
And would that involve, like, resetting would that involve creating a non-default password for the device to access it subsequently, like credentialing it, or is it?
It's sort of, it's not quite passwords, but it is similar. We put up UUIDs.
Okay.
And until a device it's much more for privacy, because it's mostly going to be either an anonymous or PIN-based authentication in the beginning. But we put up, each device has a UUID that identifies it. Until the device is owned, it puts up a random UUID.
Yeah.
So it's completely untrackable. And if you plug it in once, it's going to have one name. If you plug it in again, it's going to have another name, but it's unknown. And then once you brought it on, then it will have a well-known UUID, or at least a constant UUID. Now, maybe not well-known, but it will stay. The name will stay. Mm-hmm. And you will apply whatever credentials, you give it whatever credentials it needs to apply on that one.
Okay.
Okay, this is how we provision the devices. Because again, the security is pretty easy. We encrypt it with well-known algorithms. They're probably not going to get broken. What's going to get broken is someone figuring out how to get inside from a different way and corrupting security. So the bootstrapping process is really important. To provision it, once we found this, it needs to be claimed, and we transfer the ownership. The first things we'll do is we'll set any addressing things it needs, any access to protocols that it needs to make sure that it can talk on the network. It will send its bootstrap credentials, so that the bootstrap credentials, it can boot up again and find things it needs. That's just finding things. There's two layers to this. One is finding out where you are on the network, and one is the authorization you need to do things, and that's where the security credentials are given. So there's a credential management system. The AMS is part of the credential management system, so that it can go and ask to do whatever it needs to do. So your doorbell can play the speaker when some stranger comes up and make the dog bark, and the speaker will say, yeah, I'll make the dog bark. It also sets the role assignments, because roles are important. Not only have devices, we have devices that do things. So you need to tell the device what is the role that it's going to play in, so that it can present role credentials or respond to role credentials, because your access control may have roles defined in what they can do. And it also sets any other ACLs that it needs for the device itself, either through the APS or through local things. But once you finish the bootstrap procedure, you should have a device that's in a working state in your environment and can now play well with all the other devices.
Let me see if I understand that. Bootstrap server, one implementation would be a thing sitting in my house running the Bootstrap server software. And I have a new device that comes in, it's a thermostat.
and it has bootstrap credentials from the factory.
No, we went to the previous side was the ownership thing, so you get the.
But this is all happening between this hub kind of thing in my house and the devices in my house.
Right.
And you're agreeing to let the thermostat act as a temperature set device through this server. And then all the other devices, the furnace, you're going to allow to be a role of a temperature change device.
Right.
Am I?
You got it right. Now remember, it may be a service like this, or it may be, yes, it's all local. OCF lives on the proximal network. There is work to, extend it to the cloud, but its primary focus is a proximal network protocol. Same thing with UPnP, same thing with Ultron. This is kind of where all the proximal network stuff ended up.
So they all have a hub in your house that they're
or just a really smart device, but because you could put all of this stuff on a single device and ship it, and be fine. I mean, if you have a big enough light bulb, you could also run a light bulb. Probably will be a hub is the easiest solution to do it. But there's no architectural restriction that says thou shalt have a hub.
But you need a bootstrap server.
You need a bootstrap server or boot somewhere.
But something like your garage door opener could provide, because that's plugged in all the time, and in your house, it could provide that service for the rest of the house.
Right. Or your TV set. Or whatever. Surprisingly, Samsung is the biggest booster of this architecture, so see it in your TV set soon.
Yeah, so they're bragging that everything from Samsung is now IoT enabled, 2017 or 2018.
Pretty much is.
And it's obviously
It's OCF. It's right now it's OIC 1.0. So we did at CES, we had a booth and we did all the who works with who and all the interoperability stuff. So yes, they were big, Intel's big, but Intel doesn't do devices, they do chips. But Samsung is by far the largest, although Honeywell has their thermostat next to the Samsung thermostat, and LG has their refrigerator next to the Samsung refrigerator, and so there's devices out there.
So during this provisioning step, if I'm the light bulb again, someone's got to tell what switches can control me, right?
Yes.
That's what's happening.
Yes. Who you don't listen to, who you can.
You're a light bulb in the living room now, and the living room light switch is the one who controls you, not the bathroom light switch.
Yes.
Okay.
So that's your role. That would be your role on the group that you're in, so that when the living room says turn on the group. Now, in all fairness, OCF is much, much weaker than Aldrin was in lights, and we will make sure that group stuff works. Right now, you have to know every single individual light as a electric controller, which is fix it. Okay, the ACL, the APS, which is part of the credentials services. I'm going to probably go through this too fast, but that means I can go back. So OCF is a concept of a secure resource management. This manages the resources. Well, it provides a policy engine. So it manages the resource. It means you, the light bulb, can only talk to you, the light switch. It's part of the CMS. I can't cut and paste out of PDFs or something. But it contains the resource manager, which manages the resources. The policy engine, which basically is a security rules engine, as opposed to a device rules engine. It says these are the rules of the connectivity between the devices. Who can do what? Who can talk to whom?
So is this like a software object? So every device that has a secure resource, a secure resource manager?
Or can offload it to something else there. If it can be provisioned to say this is a secure resource manager you're going to talk to, you either locally or again you can be provisioned to say talk to this guy over here.
Well, I would have thought it would have to be local because I'm a light bulb and something says, hey, turn on, and I say, well, let me check and see if you're on my ACL list.
But you could be provisioned to say, I got to go talk to Joe, who's going to tell me if you're on my ACL list. So it's not mandatory, it's local. And in some cases, it will be local, in some cases, it will be off forwarded someplace else. Now, because these things need to persist, it's unlikely the light bulb's gonna have one of these, unless it's got a bulb load of flash, but it might, you never know. But if it does, then it can, because you do need a persistent store. And so the OCF specifies how you should treat the persistent store to make sure that it cannot be tampered with, because it's a weakness in the system. So in order to get certified, you have to pass the persistent store test as well.
So for instance, the light bulb would say, its persistent store would say, that's my resource.
Right. And that's all it has to worry about.
I'll ask it, and I know how to talk to it because I've got it flagged.
Yeah, and that's all it has to know. And it just has to protect that one bit of information, which is this guy over here. Other than, otherwise it has to protect all the ACLs and all the things. And that's part of the platform secure storage, which is, the persistent data has to be kept secure. The integrity has to be maintained, because it's one of the easiest vectors to attack. Is you just change the little pieces. Go talk to this guy for authorization, and sure enough, that internet crockpot is opening your front door. Credentials. So obviously authentication is important. So the OCF provides a number of forms of authentication. So pairwise symmetric key, which is basically we both have the same key. A group symmetric key, which means that all the members of or the members of the group have the same key and can talk. And both an asymmetric authentication key and an asymmetric encryption key. So the asymmetric authentication key is that I know it's you, and then there's a different path, you know it's me. And then the same thing for encryption, because things need to be secure. This goes a little bit more into, although we use DTLS on the transport, you can secure objects above that as well if you want to be truly paranoid, which some people want. Credentials also contain certificates and the plain old password. So you could have a light bulb that has a password.
So what algorithm are you using?
There's a bunch of them. There is a standard one for each of these, and then there's the, going further and further. There's a elliptical curve one for that. But they specified one that thou shalt, and then a bunch that you should. I can point you at the website that lists. There's a lot of them. There's 6 or 7 per thing.
So if it's TLS, it's an agreement between the edge device and the server hub thing. And
Just to encrypt the traffic, that's all.
So you can.
This is more for authentication. Once you're authenticated and you're talking above the transport level, this is what you can do. This is your authentication stuff and your encryption stuff if you want to re-encrypt, because maybe you've got the anonymous TLS and you want to make sure that just in case it wasn't the guy you're talking to, that when they get this data they can't read it if they're not the right guy. So this isn't mandatory, but this is pretty important. So the OCF has a section on how you should boot your device, because it's one of the easiest vectors to get into the system. So basically, they're asking for T-voication, which is cryptographically, verify that the image you're booting is the image you shipped. And each subsequent bootloader, so if you have a 2-stage bootloader, the first bootloader verifies the second stage bootloader, which verifies the target. And they really ask that you use the one-time programmable memory for at least one of the keys, so that you just can't break in.
How do you handle firmware updates when you've done that?
So that's why you have two-stage bootloaders. Only the first stage bootloader is the one you gotta get right, because you can never update that again.
Right.
But then you can update the second stage bootloader, or the second stage bootloader can update the target. But you gotta get back past the first stage bootloader. So normally in that case, the first stage bootloader, one of the second will be able to verify the second stage bootloader. And update that. And usually the second stage bootloader can update the target. You could go with a well-known one-stage bootloader and have the target. There's nothing wrong with that. Either there's just less room for recovery if you screw up a big image.
Eventually, when you get some kind of image, whichever image you have, it's going to have a new cryptographic validation key or signature or something. And that has to get written somewhere.
No, it has to, what it has to do is, it has to be signed. It has to present a signature that the first stage bootloader or the previous stage bootloader can verify. So the first stage bootloader has basically a certificate or a key inside it. It's usually an asymmetric key. So it's the private key, or it's the public key of the organization. The organization signs the image with their private key, and the bootloader goes and verifies the image with the public key, saying, this is from Acme sledgehammers or whatever it is that Coyote's buying.
Mostly animals.
Just Acme Corp. They make a lot of products.
So that's not something, the public key is not something you have to worry about anybody leaking. So
You can leave public key everywhere.
You might know what the one-time.
Well, because you don't want to change it. The one thing you can't do is change that public key, because then, somebody else could reprogram the bootloader, and then.
Oh, so you really mean non-writable? Non-writable from the outside.
Yeah, yes.
One time.
One time, you write it once, and then never again.
Yeah, but if that
doesn't have to be
if the private key associated with the public key is ever compromised, you're screwed.
You're screwed, yeah, you are screwed. Which happens with DVDs. It happens.
Nothing is perfect.
Or permanent.
Or forever.
Okay, what's missing? Well, we haven't figured out how to specify a secure software update. We know how to do it, we discussed it here, but there's no specification on that, and that's just a matter of sitting down and making sure the security experts agree with the protocol guys to just specify, which just ran out of time. The other thing we're missing is ACLs for a specific application and not a role. So that if I have a door unlock app on my phone, only my phone's door unlock app can unlock my door. But we'll get that.
So that would just be guidelines, or if you're creating this class of product, here is how the ACL should be configured?
No, it's more adding to the ACL to give it another field, which is a subset of the group of the role, which is this instance of the role has this privilege.
Okay.
Because the last thing you want is something that's part of the door unlock group, unlocking your door, and you find out it's some random thing on your Z-Wave network.
Right. Right.
Because we are going to be bridging all the protocols to everywhere. That work is underway now, and until we get a clear winner, it's going to continue. It's nightmarish how that can happen. Because in that case, the Z-Wave device can unlock your door, can turn on your stove, it can do all the bad things that we've heard on happen.
But with this, you're saying you could brand it, you could say.
Only this application can change something, and not the generic role of this application.
Okay, so now it's gotta be however the Schlage door locker that can
With
unlock.
this specific identity?
Yeah.
The other thing we're missing is multicast. And that has a lot to do with security, but it also has to do with protocol in of itself. Even though we have a group symmetric key, we are still a unicast transmission. So if I want to turn on all the lights in the room, you're going to see every light go on one at a time. It's not so good if you're really trying to use this technology as a, I don't know, in theaters or holding things or wherever you want all things to happen at the same time. So that's work that's going to be done. And now I'm going to go into the part that I can't talk about. So in my view, this is a personal view, the LCN Alliance is about 2 years ahead of the OCF when they merged, partially just because of the number of devices out in the marketplace. It's an older protocol, it was more developed, there was a lot of devices.
That was All-Join, is that?
All-Join was the LCN Alliance protocol.
Right.
It was originally developed by Qualcomm, Technicolor through and Keo. Well, Qualcomm tried to sell it and found out that it's not good at selling protocol stacks, so they donated it to the Linux Foundation. Technicolor, who had a similar stack called Keo, it was the only difference was one was a publish subscribe, the other was a query response. But Technicolor saw it and said, "Oh, they'll donate Keo to the same group," and All-Join was both born, and that was before OIC. So with the merger, there's a bunch of things that I think the OCF will pick up. One of them was devices, and was streaming. The OCF doesn't stream yet, and it needs to. You can't. All my examples of barking the dog don't work because we don't know how to send the dog bark to the speaker yet. But UPnP does, and All-Join does. So OCF will pick up on that. I think it's gonna do well. It's lessened the number of protocols you have to worry about, but we still have a long way to go. Probably another couple of hateful things to say, but I won't anymore. But I think it's in the long run it will make it easier.
What about things like Weave and HomeKit?
Personally, I go back to my days. I'm old. I did the network thing. I was the U.S. editor for ISO, for the transport layer for ISO. So I was ISO guy. I knew all about TP4. I thought it was going to win. It was great. It was great. TCP1. But at the time, we had products like AppleTalk and NetWare and Banyan Vines and oodles of these proprietary protocols, and which is what we see today. There's no more AppleTalk. Apple doesn't ship AppleTalk. And I think HomeKit's going to go the same way. Once there's something that really works, that everyone picks up on, that's the way it'll be. But in those days, the thing that caused that seismic shift was the web. Before the web, everyone had equally bad information processing services. And something came along that changed it.
So I have a question. If I'm a device maker and I want to make a gadget, and I want to use this protocol, are there license fees?
No. It's open source. It's open source.
Do whatever I want. I can get the specs. I can get the.
So there's an advantage. There's one advantage to joining the OCF, which it does constitute as protected from any random patents. So any member of the OCF will not be sued for using the OCF patent, by any other member for patent. But that's about the only advantage. There's an open source implementation, which probably takes a lot of the legal stuff off of it. The OCF is a FRAND license, so it's a fair and reasonable, yeah. So that if you get charged royalties, everybody gets charged those royalties. If you remember, you don't get charged royalties, of course, but then you spend thousands of dollars being a member. So it's what happens there.
And are there any devices that use it?
Right now?
Yeah.
Samsung TVs.
TVs, yeah.
TVs, let's see, what do we have? We had.
The ones that listen to you, right?
Yeah, they all listen to you. Yeah. It's not just the Samsung TVs that are listening.
You talked about Honeywell thermostats?
Honeywell thermostats, well, Honeywell thermostats are kind of cheating. They're still using a cloud API, but they can talk to the cloud and back down.
So the thermostat connects to your Wi-Fi.
Yeah.
To the cloud.
Right now there's a lot of that where everyone's did their proprietary cloud API, and they're just doing little work to talk to their cloud to come back down.
I guess if you're a device developer, why would you, so maybe just contrast this kind of stack to what exists now or what is available to device developers now, and does this represent, are you solving problems for developers with this, or are you merely saying, well, here's a standard
Well, the part of it here is a standard. I mean, the big guys love standards.
Yeah.
You know, I mean.
It doesn't make your life any easier as a device.
It makes it better in some ways. So, you know, the competitors are HomeKit, Thread, Weave, Brillo. Now, Thread, Weave, Brillo, HomeKit lock you into that vendor's vertical.
Yeah.
So you're free to that. But there's other protocols like MQTT, UPP still there, a bunch of other, you know, Zigbee, do Zigbee stuff. And I think it's an alternative right now. I think Zigbee figured out that they were losing, so they came up with .dot this last year. .dot is taking all the Zigbee stacks and putting them over IP, so that there's a much saner device or a much more even device model for Zigbee devices now, instead of having to learn each profile. What you used to do, and what you have to do with Bluetooth now is you have to learn every single profile for each device. It's a little tough on the developers. So this is an alternative. It's no better, it's no worse. I think the security model will be better because they took what they had and they took what AllJoint had, which was a pretty robust security model, and they merged them. And I think for security devices in the future, that's going to be the most critical thing. I'm still afraid that my internet-enabled Chromebox will open my door, and and if I'm scared, well, maybe the rest of the world isn't because they don't know it could, but they should be.
So how do you tell a light bulb, or how does something know that it's a light bulb and not an internet controller?
Well, I mean, the light bulb knows it because it's been told it's a light bulb. The software on it says, I'm a light bulb.
Well, who loaded that software?
So the manufacturer should have, I hope.
Right, so if somebody had a counterfeit light bulb that said it was a...
Yeah, you can do that. I mean, we had the refrigerator that was a spam bot. Was one of the first internet hacks. Was the refrigerator in England just spammed millions of people because it could. And maybe if we adopt a protocol like this, we can cut down on the bad behavior of these devices. I don't think
I'm just wondering how it.
You still have to have trust, right?
You got to trust that you bought a manufacturer, you bought a light bulb that from a vendor you trust.
So right. there's nothing is configured to know what the legitimate things are, or there's no certificate authority kind of.
There's no. Well,
it seems dangerous.
Yes, you could put rogue devices on that claim to be legit, and they could do bad things
because they lie. Yes.
There's no way.
It doesn't sound like it's very hard to do that.
No, no, but the theory is you need a human to say that I trust this rogue device. So yes, you could do device phishing the way we do spam email phishing now. But I could give out batteries or something and just have them figure out the Wi-Fi, corrupt your home. Yeah.
Okay.
Sorry.
The people use Kaspersky, you know.
Proximal network, what does that mean?
That means a local network. Your in-home network, and it's not going out to the internet. It may be a single net. It may be your wired internet, your Wi-Fi network, maybe a Zigbee net.
Like inside your home, your
Inside your house.
192.168.
How does that? How do you preclude that? I mean, how does this standard manage?
Well, because co-op doesn't really work over the internet yet. It works on the local thing. If you wanted to mandate it, which we don't, there's ways of doing that with opt-outs, which the TCP does. But it's a way of talking about things that are near as opposed to going to the cloud and back.
So your protocol won't say anything about this controller box not to do
It doesn't specify how to do that right now. It doesn't matter.
That's okay.
It doesn't matter. I mean, there will be a specification on best practices on that, or maybe even extending the OCF protocol into the internet, into the cloud, because it's important. But right now it doesn't.
And you also don't say anything about kind of an input firewall or anything.
No. That's not quite within scope.
Is there any vision of the ultra large boxes? Thousands of things where it's impractical for humanity.
Well, there is work in the what do you call it? It's not. I'm in a smart home, but there's another. which is similar to the city side stuff, with the light bulbs there. And there's work going on in that, on how to do the provisioning there. I'm not as good at knowing all the details there. It's not specified, it will not be specified in the 1.0 release, which is coming this quarter, next quarter, I guess. But yes, they're looking at it, because it's part of the lighting problem we have. With the shared problem of we're sequential right now in our access, and that doesn't scale. So we'll fix it.
Right, how do you handle roaming? So if my phone is part of the proximal network part of the time.
That's the easy comes back. So you probably have to get some sort of gateway into your network. I mean, XMPP is one, although this has been some security holes there. But there'll be something. I mean, again, this is going to be right now. There's no standard solution for that. VPN back in something to make it look local. Will there be other solutions? There's a lot of people looking at it. There's a lot of people that are going to fix this problem. It's a known issue.
Yeah, I wasn't thinking so much about how do you access it remotely. It sounded like a very static definition of the network, and those things come and go.
They come and go, but they persist. Your phone is always your phone, so anytime it shows up on the proximal network, it will be your phone. It'll be authenticated as such.
So you introduced a couple of concepts. One's a bootstrap server, and the other one's an AMS.
Yes.
So I understand the bootstrap server is part of the proximal network, right? Any entity in the network can become a bootstrap server. How about the AMS?
The AMS, well, it's not. There has to be the function of the AMS. It could be local to every device, or there could be a central AMS. Right? It's more for scalability to have an AMS service on the network, because it's really hard to provision every single device for all the things it needs to know about, especially as we get more and more devices in the home or in wherever we are. The AMS centralizes that, so you're only provisioning against one instead of
also in the proximal.
All the stuff I'm talking about was basically in the proximal network. How we define the proximal network will change as we go to like streetlights and buildings and cities. But there are some properties of the proximal network that everything's accessible. You're not going through firewalls. You're not, it's semi-trusted network.
You also took the example of sort of an app on a mobile device participating in this. So is the thinking is that the app on the mobile device acts like an entity on the network?
It's a device. It's a device on the network. In fact, each app is a device on the network. It's either a client app or a client device or a server device or a client server device.
So it's not the model you see these days, like Nest, for example, we talk to the network, which talks back to a cloud service.
Right, now this would be right on the proximal network and
I had one other question. You mentioned there's an open source implementation.
Yes.
And this is going to be an open source reference implementation that people can use to build devices.
Yes. There's what's called IoTivity. There's two flavors of it. There's IoTivity, and then there's IoTivity constrained. IoTivity runs on Linux, Android, Mac OS, Windows. IoTivity constrained runs on Zephyr, two other real-time OSs, two tiny devices. So if you're building something small like a sensor, you'd use IoTivity constrained. If you're building a more reasonable size device, which nowadays, I don't know, I get a little tiny things for Linux, but you'd use the regular, the more fuller version where you can put things like AMSs and those types of services.
Do you have any information on footprint? For
there is guidelines for footprint. There's class 1, class 2, and class 3 devices. I don't remember what they are, but there's class 1 device we don't do anything with. It's so small it's not even funny. It's like a less than 100K device. 100K to 512K is class 1, 2, and then the big step was a class 3. And so we go after class 2 and class 3 devices. Class 3 doing full IoTivity, class 2 doing IoTivity.
This activity constraint, give me a picture about how small it is. Can this be a module? Is there metals?
Yeah.
I mean, it's 100K.
It's a bare metal library.
100K, we're looking at 100K devices, so it's gonna be very small. I just started playing with it, so I'm not quite good at it, but I do have a target I want to put it on, which would be very cool. It's a thread device, so if I get it on that, then I'm pretty confident I can get it just about anywhere. Obviously, with tiny sensors, it won't fit, but it's got to have something to communicate with communication set capability.
But did you just say how small you were personally?
We got 256K, so we're huge.
And you say it's CoAP as the
protocol?
So it's gonna be only an IPv6 network?
It is currently only an IPv6 network. There is a waiver for IPv4 nodes.
Okay.
But the standard says thou shalt IPv6 unless you get a waiver.
Okay.
What support is there at the moment for HA and perhaps redundant services? So, you know, if one of my key services is down, can I still operate my door locks? Can I operate home medical equipment on?
There's nothing in the protocol that prohibits that, but it's not built in either. Right. I mean, it's all the roles you have. So if you have redundant roles for door lock, then you're okay.
Right, but can I have redundant secure resource managers, redundant AMSs and CMSs?
Again, the standard doesn't prevent it. I think you have this, but they don't specify how to do the syncing of the data, the data consistency, which you have to do. So it would be left as an exercise to the implementer to do all the hard parts of making a redundant system.
And does CoAP support routing or not?
CoAP is routable.
So I can support dual paths for resource.
Yes. Well, yeah, it runs over IP, so yeah.
Anything with HTTP you can do with CoAP.
Yeah.
The optimal network is the design feature, it's the restriction and restriction.
Excuse me?
The optimal network is the restriction or it's a design feature. Like the intelligent put this as a proxy network or it's the current.
There's things that you don't have to worry about if you're a proximal network, so the architecture is geared towards that. There's nothing to say it won't work, but the thing is that, we're not looking at firewalls. That's the big thing. Firewalls kill, and we're not gonna solve that problem. So when we go to a non-proximal network solution, we'll figure out how to do firewalls. We'll figure out how to do all the security gates you got up to keep your home net secure. That nice hard shell that everyone goes up.
I just want to point out, it's quite feasible to use CoAP through a router.
Yes, it is.
What you're saying is, it's just not specified by your solution.
Right. We simple, CoAP does, it works.
I don't want people to have the perception that CoAP can't be used to connect out with the rest of the internet, and it certainly can, and there are ways that you do that, but we do that all the time.
IPv6 all the way out.
Yes.
Yeah, it doesn't have to be IPv6 either. You can do CoAP over IPv4 or 6. It's not necessary.
Well, so
they may specify it that way. CoAP works over IPv6 and IPv4.
That's true.
Application network. It's application network, right?
Yes.
Yeah.
It's just like HTTP.
Yeah.
You layer over UDP or TCP. It's just compact HTTP.
Yeah.
It is, yes. 98 numbers. Yes.
And you mentioned a lot about the protocols of this communication. We haven't really said what kind of protocols are used in this solution.
This is the CoAP protocol, so it's basically gets and puts over CoAP. So anything that CoAP runs over is what it.
But I'm not familiar with the protocol.
No, it's
like the field.
All right. So right now, the payload is I'm gonna get this acronym wrong. CBOR, which is the binary pack. But there's also the ability to use JSON over this as well.
It's just like HTTP. It's got headers and it's got bodies. But bodies can be anything. CBOR is what's common because it gives you a way to give end-to-end security. You can sign or encrypt your body.
And as an attacker, the HTTP is exactly what we use.
So, and it's got headers, but it's binary fields as opposed to hexadecimal. But it's very detailed. It's modeled very, very closely to HTTP.
So big, beautiful, complicated functions with lots of heads.
They're finer. It's not touch wheels, they're finer.
And the Seaboard parts are short.
Yeah,
It's like 12K or something.
This is the web, not creative. Tell us a little more about what you're concerned with.
Oh, just every time where I've seen somebody make a really robust, sensible algorithm or protocol like SIP or something, it's beautiful all the features it offers, but you have the most insanely complicated parsers. And I was putting in one Cisco phone, and it actually parses XML settings. And it's so complicated, they have multiple parsers that disagree on how they parse their own configuration file.
It's a little more straightforward than pure XML, yes, but yeah, I think we're going to always run into that. We're dealing with complex data. And even though this is a binary format and it should be quite straightforward on how you should send it, I'm sure there will be misimplementations. The one thing we're going to be working on is to make sure that IoTivity is the golden standard that is really truly conforming. And so right now, the big push is to make sure that what's in IoTivity is what the standard says, and what the standard says is in IoTivity, so that if you can test and have confidence, at least you'll be conform and you'll be interoperable with probably the largest deploy base. I have spent most of my career writing network protocols, and some of the time was spent actually writing the protocols, but the most of the time I spent was interoperating with someone else who wrote the same protocol differently. And I don't want to never do that again.
I have another question. We're talking about light bulbs. And we're talking about the devices can be clients or servers. So if I have a light switch and 10 light bulbs, are the light bulbs HTTP servers and the switch is doing click.
Yes.
Okay.
It's broken. We'll fix it. What you really want to do is you want to put them in a group and have some group controller, some group controller determine the lights on, all the red lights on, so that your light switch doesn't have to be smart about where all the things are, because it's tiny too.
Yeah. I'm used to MQTT, which doesn't do that.
No, and AllJoint didn't do that either, so we'll fix it. Like the marriage of AllJoint and OIC is still young. A lot of things that the AllJoint did right that OCF didn't, as long as OCF did right that AllJoint didn't. So
what odds are you giving us that 2 years from now you're going to be here talking about this protocol and not saying, well, it didn't work?
It's not that it didn't work, it didn't get adopted.
It didn't get adopted.
It didn't get adopted. I mean, I have no confidence that I will or will not, because I bet on ISO. So my track record sucks.
With ISO, we wouldn't have made IPv6.
Right.
Yeah, well.
So, you know.
So, I'd like to push back on that. What prevents you from having a hub that has a logical concept of the lights in my living room?
Nothing.
And my light switch talks to that hub and says, turn on the lights in my living room. But that hub knows that there are actually 20 lights in my living room, and it sets all the put lights.
Right. There's nothing preventing you from that. The only difference is it's non-standard. So that you would buy mine or you buy yours, but we couldn't put both of those hubs in the same place and have it work the same way for the same app.
Isn't co-app point-to-point?
Yeah.
So
we gotta fix the multicast problem. We gotta fix the multicast problem.
So the light switch would has to, by the co-app standard, has to talk to every single endpoint. You can't talk to it.
No, it can you can have a logical concept of my living room light.
Right, and that's what you did. So in AllJoint, we had the lighting
Right.
service and the lighting controller. Applications would talk to the lighting controller, and they would talk to all the LAN services out there. Now, in AllJoint, we kind of cheated because it was a network, it was a routing protocol, so we would just say, turn on the lights. Because this is co-op based, it's going to be a struggle. There's going to be some hard choices need to be made, but we'll figure it out. Just to get the timing right. Not be able to do it, but to get it so that it's not a sequential big.
You can't multicast it.
Right.
But there's no reason you can't organize it.
No, we can organize it.
Hierarchical fashion.
But once we crack that thing open, I think we want to get the multicast right too.
Sure.
Is there any vision of the device not knowing what it is?
No, because it's gotta know something about itself. Now, we have this argument about sensors and windows. Is the thing a sensor, or is the thing a window with a sensor? And in some cases, it's just a sensor because you went down to Lowe's and you grabbed a sensor and you slapped it on the window, and it knows how to talk sensor talk in OCF. And so, no. But if it's a window that has a sensor and it knows it's a window, then it should say it's a window. Because when I say, Alexa, which windows are open, it's about to rain, I want Alexa to tell me which windows are open, and not have to know that sensor is on a window or on a door. So it's whatever the device thinks it is what it is.
So if you have a device always on your refrigerator, doesn't know whether it's a refrigerator or a washer, what it's for.
If you can provision it to be something, again, it's the belief of the device is what it is. Or whoever provisioned the device.
It's really the co-op resources that it exposes to the network that say what it is, and the co-op resources that it listens to or that it gets that says what it does.
I think so. Or what the co-op resources it exposes say what it is.
So can it self-configure? Like if I drop a switch into the house, can the switch say, hey, I'm a switch, are there any light bulbs that need turning on or that I should be controlling? Or
Well, I suppose with an app, you could go out and ask, once you're on the network, you've been given the right credentials, sure, a light switch should go out and find all the lights on and could do whatever it wanted to, because if you provision for group credentials for lights, right, as opposed to for the whole house. If you've got it down to a smaller security domain where only my room has its own credentials and my living room has its own credentials and my bedroom has its own credentials, then no, the light switch would have to play, well, it could play in 3 domains, but again, it's all provisioned to be.
So in case of the light of example, the current restraints are like we have this issue of individual tasks talking to. So what if I have hub which talks to all the end devices on a local protocol?
You mean just a front end? Yeah, it's
Yeah,
pretty.
is still with the OCF standard or Android.
You could present yourself as a group. Yeah. I mean, again, there's going to be a lot of bridges out there, and that's the classic bridge protocol. That's how we talk to the Zigbee stacks, NOcean stacks, the all joint versus. We do have a bridge between OCF and all joint, so that as an OCF device, you can manipulate all joint devices and vice versa. And there's going to be a lot of them. I mean, Microsoft just got that with OpenTTT. There's a bunch of work going on because we all realize that this multi-protocol environment is really, really broken. There's no reason for it because we're all trying to do the same thing. We just can't agree on what it's not.
So I have a question about the IoTivity implementation. Is the expectation that the vendors will actually use that to build products, or the vendors are all?
Samsung is, so yeah.
So Samsung is actually building their products off the same code.
Most of the IoTivity committers are Samsung employees, so they're kind of funky. But there are others.
No, I get that, but like I'm asking you perhaps a quick nuance. Like for example, all Android devices are built off the Android code base, right? But the question is this the same way, or is that people are building to a standard versus they're building off the same code base?
This is a standard. There happens to be one code base now, as opposed to AllJoint, which was an implementation that was actually no standard to it. It was just if you use this code, it will work. So we are going to see the interoperability problems that have plagued us throughout all the standards. You spend a little bit of time writing the code and a lot of time interoperating with all your competitors. That's just the nature of standards.
If you want to decline this question, that's fine, but if you're kind of new to this world, who are some of the big guys backing some fairly complete alternatives to this?
So IBM's big within QTT. So there's a bunch of silos doing Zigbee.
Is Philips in any of the camps?
What's that?
Philips.
That's a Zigbee implementation. I mean, I don't think they care. They just there's a lot of people trailing who are watching and waiting for the winner instead of trying to be first. They only want to do it once because the danger of jumping in now is going to do it twice. Whatever you picked was the wrong thing. And for instance, Electrolux is huge in the long term, massive.
And now they're huge in OCF because they know it's important for their customer base. But they've got a number of devices that are going to be shipping, or are still yet to be shipping, that they're going to go through as alternate devices because it was the right thing to do at the time.
Good question for you. There are certain environments in which, the prevalence of these embedded devices is getting more. For instance, in a hospital setting. And even today, if you just go down a corridor, if you could just capture all the signals, what is going on, it's just, insane and a tendency to become even bigger. People don't have in the same protocol. You can have, like in a small space, you have several of these protocols, and being an among us mass, and ultimately perhaps one interfering with the other, not in high level, but diminishing the quality of what is done or could be done.
Yeah, also, well, because unless everyone speaks the same language, you need to translate, and something is lost in translation every time. And if all the devices in the hospital were speaking the same protocol, they could do more than they can do now with each of them talking to their thing on their own protocol.
But okay, I just don't want to be obtuse with this, but I mean, other providers of equipment, and I mean, nobody is really talking to each other. I mean, there is not a real, serious effort to have, once in a while it's good to have some homogeneity, but I mean, this is like, it's basically a free for all.
Right now, we're in the spot where the vendors think it's to their advantage to be proprietary because they've captured the market share. There'll become a tipping point where being open captures the market share because it's better for the customer. We haven't got to that point with the IoT yet. When we do, a single standard will start to emerge. So we're not there yet.
If I'm a manufacturer of LED light bulbs and I only want to manufacture one product, it's capable of color changing, but I want to sell it as a white only bulb and then sell you a license key to turn on color changing capabilities. How does that fit into the model today?
Well, the device is in control of the resources it exposes. So that in the OCF, you wouldn't expose hue or chroma or any of the color things that a light bulb has. You would say, I've only got on and off and maybe intensity. Right. And when you get the key in, you can suddenly turn on your hue and chroma.
So I also have a licensing capability.
Right, well, you'd have to, yes, that right now, we don't specify licensing, but there's one thing about the OCF is it's truly extensible. Because it's just a path, there's a method for OCF standard paths, and then vendor extensions, and you just put the license.
I was just curious, I believe Google is trying to make their protocol good for the enterprise also.
Of course they are.
And is that?
The only thing I have against Google is that I'm the product, and that makes me not want to use them. Because I'd rather be the customer, it's a lot nicer. And Apple has HomeKit. Apple is a wonderful organization if you stick inside that silo. There's nothing wrong with it, but Apple gave up on Apple Talk because TCP won.
So for the OCF, would you say their target is the home? Or more
The first target is the home.
It's clear that a lot of it is because Samsung.
Yeah, Samsung is a CE vendor.
They made a bet on that.
Yeah, the first target is the home, but healthcare, industrial, the what do we call it, the neighborhood land or the city land or the city.
Smart city,
yeah. Well, I mean, they're part of it. It's just you can't do everything all at once. So the 1.0 release is only going to have the smart home profiles in it, and not any of the other ones because they're not done yet. That's just the nature of what went first.
Yeah, would they have like a profile based on the device footprints? Like device application like Bluetooth, memory footprint, and based on that you can compare with certain features of the program.
Well, the way it works is that there's a base
base things you have to comply with. And then there's other things that are optional. So it's not based on the footprint, but it's based on the minimum interoperability standard. So for instance, a light bulb has on and off. You have to do it. Other than, and what, intensity is optional, hue is optional, chroma is optional, ramp time is optional. All the things that make up a light bulb, which get, I don't know, it's like half a dozen or so. I don't think I've enumerated them all yet. That you can do, but you don't have to. And so if you have a tiny light bulb, don't do it.
You don't talk that this OCF standard supports like this. It's just a communication protocol, not actual implementation.
The implementation is IoTivity. I mean, it's a standard that says that if you're going to talk OCF, here's what you do, here's the paths, here's the values for the different things. Let's do light bulbs. You have a basic binary switch on and off. You have a range for intensity that you can set. You have the chroma values. I don't know how they're encoded. You have ramp time, which is how long it takes for the light to change states. Those two more. But there's all these things, but only on and off the standard.
So first I query you, and I say, what features do you implement?
Right, and it comes back and says,
here are the resources that are settable.
Yes, here's the resources, here's the resources that are settable. What's nice about the merger between AllJoyn and OCF was AllJoyn already had introspection, which is, I write an app that knows nothing about any device. I can query the network. So the OCF 1.0 release will have introspection, where you can query the network on what's out there and what the capabilities of the devices are, which is kind of cool. Because no one knows what all the devices are.
So you said I just broadcast, I say, hey, everybody, tell me who you are and
Pretty much,
what you do.
Yeah, you get back, it's not, you get back the URL that says, or a path that says, here I am, you query the path, and it tells you more.
It's a hierarchical thing.
Yeah.
So a light bulb might have 6 light sources that it's capable of controlling. If it's a long string of light bulb with 6 individual emitters, it might say, I'm light bulb A. You say, okay, light bulb A, what do you got? Oh, I have 6 light sources. So light source number 2, what do you got? I got on off. I've got intensity. Light source 3, what have you got? I got on off. I've got intensity. I've got red, green, blue, and I've got blink or something. So you kind of have to recursive dig your way through to find out what everything is out there. And I suppose through, I don't know, roles or groups or something, when you say what's out there, you might not find out about the refrigerator. You might only find out about the light bulb.
Yes.
Because you've got something that tells the something.
The ACL may prohibit you from finding out everything
that says,
You
oh,
have
this
to say
guy's
who you are.
asking.
You say, I am so-and-so, and I'm asking this question, and I say, no, I don't answer that kind of person.
Yeah,
Right.
Okay.
Yeah, so you can,
and that has to do with the provisioning of all the bits and pieces as you're building this network.
you got it.
But it's something everything has to do.
One more question.
Sure.
Is there any concept of a fail-safe state for devices if they lose network connectivity? Like if the lights come on?
That's currently beyond the specification. That's a manufacturer's add-on. So there is the concept of sleeping devices and unconnected devices. But what they do in those states is not standardized.
It should be, right? It should be the part of anything, but anyway, one of the safety concerns.
I don't know. I mean, there's an advantage to standardization and there's a disadvantage. The advantage is that you basically talk to everything there. The disadvantage is that standards tend to tamp down on innovation because it's the way you do it. And it's writing standards tricky in that you don't want to be too oppressive in what thou shalt do, because thou shalt do the shalls. You should do the shoulds. You could do the coulds, but you shall do the shalls. And that can inhibit some creative ideas.
I think you have a hard time defining what is acceptable. Is it light on or light off? Maybe one of the cases where
No, we are defining some characteristics of the new actually and device type like this service should be provided for fixed and this should be can be standardized.
I think that if anything, it should be provisioned and not standardized.
And there are all these products that we're using this. So Samsung maybe was up to Samsung to have them, Samsung server somewhere to
Of course, Samsung wants to own the world, like Google wants to own the world, like Microsoft wants to own the world, like Apple wants to own the
I mean,
world.
like, Lowe's has some home automation stuff, but if you don't pay $10 a month,
It goes away.
Like, you can't.
I have a
regulate all your own.
quirky air conditioner, which I think may no longer work, given that Quirky just emerged from bankruptcy, and it's not clear what they're doing with their servers. So you run that risk all the time. With the standard, at least, the chances are you can plug something else in for that proprietary gear and it will still work.
But you can have that connection to the cloud totally outside of anything to do with OCF. And that can be Samsung proprietary going to the cloud. That's not really OCF concern.
It's not.
OCF is how do I have the devices in different manufacturers.
What I want to do is go to Lowe's and buy a light bulb and plug it in and have it work on my network in a smart way. The way I go to Lowe's right now and buy a network and plug it in, I know it fits the slot, and when I pull the little chain on the light comes on. I want my smart bulbs to be like my dumb bulbs.
You want to really use Google Home or Alexa or whatever.
Doesn't matter.
Whatever speed manager, have it go.
It's just gotta work. That's what I want.
But this is one kind of device. For instance, you have devices that would just monitor a situation. For instance, these IoTs are attached to what is called a smart package, which people intend to monitor, supply chain of foods or movement of particular chemicals and stuff like that. It's a different thing. Because you continuously would like to be dressed in longitude, latitude, what is on, what is on, what is off.
Wide area IoT protocols. Yeah.
So it's
That's different, but that's not what this is solving, the first part. Eventually it can be solved, but it's better to do one thing really well than everything poorly. And so both the OCF and I'll join in, and UTP went to let's get the proximal network right. Because you don't have to worry about all the things that the wide area network brings in, which is the connectivity issues that you always have. The security issues are worse, although we should keep the same level of security. But it's mostly the connectivity, that firewalls get in the way, that all sorts of things happen.
But for your example, you could build a device that has a cellular modem on it, and you could, as this package tracking company, set up a server somewhere, and all of your little devices have that as their, what did you call the thing that's in your house? Not the bootstrap server, but whatever that object is. And they can talk over the cell phone network to that server as they're moving around the planet. And as long as they have cell connectivity, they can say their latitude, longitude. And when they don't, they maybe will remember it for a while. So I don't think this protocol prevents anything like that.
You can go as far
They
as
maybe just don't do that as part of their reference.
No, it's just a sense that is, you are dealing with, I think, with totally different things, I mean, something that is really mobile, and you intend it to be mobile, and you want to know when it is mobile, when it is moving, when it is stopped, because,
well, that's location services, so that's a different thing.
It's a total different thing.
So location services almost exists in alternative woods, it does exist in the LTE's specifications where you can figure out where things are and report on them. But what you want to do is report on the location of things in a standard way, so that you don't have to write custom applications for every single different kind of way of reporting on location services. This is one method of doing it. What you care about there is location services, and it doesn't matter what the protocol is.
It's yes and no. For instance, okay, if you look what FDA, a regulation that was written and it should have been, it is in the books, but it's not being obeyed because, you didn't have the means. The FDA wants, people wants all the foods that comes into this country to be monitored for particular values of either wholeness or whatever, for optimal transportation. From the point of departure, which then is not many times not even inside of this country, it's elsewhere with other regulations, other laws, other situations, until it comes into this country and goes to the point of sale. Now, this has been in the books to be, implemented since 2010 or thereabouts. And it is absolutely, there's nothing, and not even the devices could do it. It was just, dreamlike, and you have, legislation that was approved. Now, the only thing that is slightly smart that is done nowadays is that some people had tweaked the management that exists and has been implemented by the main truck companies, in which they monitor wear and tear of the motors to totally independent of the, let's say, simple tweaking to monitor what goes in a cab. So, but then with the refrigerator cabs, but what it starts, but what it stops, or if there is a problem with the truck, then there might be a problem with the cargo. So, but it's the old star products or whatever. It's the radio and phone thing.
It's hard, but that's an application. That's an application problem. It's an application problem. It's independent of what protocol you use to fix the problem.
There's nothing. People.
No, I mean, sure there is. Someone just has to write the application on a protocol. But this protocol or HomeKit or MQTT will not solve that problem by itself. Someone has to go write the app that solves that problem. So that, again, this protocol could do it with a couple of tweaks, especially with the wider connection stuff. But again, that's what we need. Why we need protocols, so that you only write one app and not an app for this protocol, an app for HomeKit, an app for MQTT, an app for everything under the sun. And hopefully, before my life is over, we will converge on a single IoT protocol. Because in 2025, there are going to be 75 billion devices out there.
Well, there's some numerology in that, I think.
That's what the big guys at Forrester were saying.
As long as the devices cost 10 cents each, that might be possible.
Even at $10, it's not that hard.
Scary to close the circle on the top.
How
to make my product OC compliant, like when
there's a conformance test suite that you take your device. There's we call it PlugFest. You take your device to the PlugFest, and you get conform. You can run the conformance test there, but you can also try and interoperate with anyone else who's got a similar device at the PlugFest. Because just conformance is one thing. Interoperability